Hello, today I'll be presenting my coursework 1 on regression modeling and prediction. The goals of this coursework is to predict an output variable using input features and compare the performance of two regression models, linear regression and random forest regressions. Let's dive into the details. The objective of this coursework 1 is to predict the output variable 1 using pattern input features that's labeled x1 through x30. The key questions I aim to answer are which model performs better for this dataset, which features are more important for predictions, how consistent are the predictions from the two models. Let's start by understanding the dataset. Import library. At first, I import library datasets, find the data types, and I try to change that X3 datasets into float like others. That can more easier to find the outlier and to gather clean and consistent dataset. That's why I changed to X3 dataset into floats. And then I visualize the dataset values with the different types of the floats as for the scatter plots for x1 with the y. That is show how the x1 data and y data is a dataset in the dataset as a schedule and heat map that helps to present the highlight area of signification in each cell with the different colors. What is mean? If it is number 1 and nearest number of 1 to show which show with the white color, so we can see in the data in the plot we can see that all the 1 are with under the white color. So 0.9 is slightly white, slightly go into the other color, so data find enter colors, and each cells with different colors. And box plot with x1 through x30 and also y. The box plot helps to demonstrate the summary of the large amounts of data. After importing the library, importing the dataset, extracting the value, importing, dropping any necessary columns, plotting, and I create the linear regression and random forest regression models. To provide the data for modeling, first, standardize the input feature, which is particularly important for both models. So as a step 1, I identified dependent y and independent value a's, variable a's. Step 2, split the datasets into the training and testing, with the 80% used for the trainings and 20% used for the testing. This ensures that we can evaluate the models on unseen data. The importance of the training and the test place is the training set contain known output from which the model learns of. The test sets, then the text for the text says text the model prediction based on what is learned from the training set. And for the step 3, step train and import the library for the linear regression model and import the library for the random forest and start using the function for the trained datasets. After that, predict the text results. This is the linear regression prediction. This is a random forest prediction. And visualize with the scatter plot. In each model, this is linear regression, this is random forest prediction. That helps to find results of the prediction from the datasets. And also, I found the mean square errors MRCs, and R-square score in the both model to know the model performance of each model. What does that mean? MRCs is a lower value indicate better performance, while R-square score is the higher value indicate better performance for both model. So I got the results. Linear regression, MRC is 746. R-square score in linear regression is 0.88. Random forest MRC 1053, square 0.83. According to the next results, the linear regression model performed slightly better with the lower MSE and a higher R-square score. As an additional feature, I analyzed the important feature for both models. So for the linear regression, do not inherently provide a feature input score like the tree-based model. However, we can estimate the importance of feature in the linear regression model by examining the coefficient of model. So try to find the coefficient, absolute coefficient, to figure out the important feature for both model. This is a scope, and this one is a plot. According to the plot, for the linear regression feature importance, x1, x6, x6, x7 are most top important feature. For the render forest, x2, x1, x8, x7, and other are slightly same. So x2, x1, and x6 are top important feature. This suggests that these features have a strong influence on the output value regardless of the model used. So as a final step, that incorporating the text results and visualize with the scatter plot. This is the prediction comparisons of the linear regression and the random forest regression. This is comparison tables. And as the last, this is a scatter plot for the book model prediction comparison. That helps to understand how well the model predictions match the actual value. And we confirm that linear regressions model outperform than the random forest because there's its model performance in square scores and MRC that I mentioned before. As a conclusion, prediction from both models were consistent but not identical, especially for extreme value. Moving forward, I recommend for this datasets by using linear regression for better accuracy, nice model performance, collecting more data to improve model reverse next. Feature X1, X7 were identified as the most important for prediction in both models. This is the end of my presenting for my coursework 1. Thank you so much.